whenever the vectors are given, you have to write the vectors in this form, that is x2 minus x1i, y2 minus y1j plus z2 minus z1k. If a triangle is right angled at A and whose hypotenuse is BC, then we have to show that square of hypotenuse is always the sum of squares of the other two sides. If R divides exactly at the midpoint, then m and n value is same, that is which becomes 1. So therefore here I can take vector B plus vector A divided by 2. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous sessions, we have learnt vector and the types of vector, also the position vector of any point with respect to the origin. Here we are going to study about the vector joining 2 points and the section formula, that is when a line is divided by certain point, what is the position vector from this with respect to the origin. So we need to find out the position vector of point R which divides line AB. So this is called as section formula. Now let's see here, vector joining 2 points. So here I have taken 3-dimensional axis. We have a unit vector I, J as well as K. That is, I is the unit vector along OX, J is the unit vector along OY, K is the unit vector along OZ, and we know that any vector with unit vectors can be written in the component form as Xi plus Yj plus Zk. So this is how we are going to write the position vector of any point on 3-dimensional plane. So here I have considered 2 points, point P1 whose coordinates are x1, y1, z1, point P2 whose coordinates are x2, y2, z2. Now see here, I have drawn a position vector OP1 and OP2. So I am taking the position vector from P1 to P2. So this arrow mark indicates the position vector P1 to P2. Now from the triangular law of addition, so you can see here this is a triangle. So how we are going to add the vector? If this is vector A, this is vector B, then this gives you vector C. So that is the terminal point and the initial point must coincide. So from the figure, what we can see here, I can write OP1 plus P1 P2 is nothing but OP2, correct? So OP1, P1 P2 is nothing but OP2. Now if I need the vector P1 P2, then this is nothing but OP2 minus OP1. So this is what I have written here. This is how we will get P1 P2. Vector P1 P2 is vector OP2 minus vector OP1. Now what is the position vector of OP2? That is, the point P2 can be expressed as x2i, y2j plus z2k, and OP1 is x1i, then y1j plus z1k. Now using the properties of vector addition, so we can write here x2 minus x1. So you have to subtract the components of same. So therefore here this is x2 minus x1i, y2 minus y1j, z2 minus z1k. So this is the position vector of a vector joining 2 points. So whenever the vectors are given, you have to write the vectors in this form, that is x2 minus x1i, y2 minus y1j plus z2 minus z1k. And what about the magnitude of vector P1 P2 here? So you can clearly see magnitude is nothing but it's a square root of the square of the sum of the components, that is x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. So this is how you will calculate the length or magnitude of the vector. Next question. Find the vector joining the points P2, 3, 0 and Q, -1, -2, -4 directed from P to Q. We need to find out the vector from P to Q. So how you are going to write PQ in the form of OQ minus OP. Remember here, P1, P2 means OP2 minus OP1. So the position vector of the second vector has to be subtracted in first vector. So now here OQ. So what is point Q we have? Minus 1, minus 2, minus 4. What is OP we have? 2, 3, 0. Let us write it in the component form. Then this is minus I, minus 2j, minus 4k, minus 2i plus 3j, and there is no k because 0 into k is, it is 0. Now subtract it. Here it becomes minus 1 minus 2i plus we have minus 2 minus 3j plus minus 4, there is no 0 there, minus 0k. So we will get it as minus 3i minus 5j minus 4k. So this is the position vector of the vector joining 2 points P and Q. So since you know that you have to subtract the first vector from second vector, you can directly write or subtract the components and write the position vector. Next, find the direction cosines of the vector joining the points 1, 2, minus 3 and B minus 1, minus 2, 1 directed from A to B. First, we need to find out what is vector AB. Then we need to find out the direction cosines of vector AB. So here, first let us take AB. So AB means you should know it is always vector OB minus vector OA. So therefore, here we need to subtract it directly. So let me subtract minus 1. Let me subtract I component first. Minus 1 I plus. Now subtract the second component. Minus 2j plus 1 minus of minus 3 becomes plus 3k. Now here we have minus 2i. Next minus 4j plus 4k. So this is the position vector of AB. Now I need direction cosines. To know the direction cosines, I should know the magnitude of this vector. So let us find out what is magnitude of AB. So it is square root of minus 2 whole square plus minus 4 whole square plus 4 square. That is the square of x, y and z. So minus 4 square which is 16 plus 16, 32. 13 plus 4 becomes root 36. Since we are talking about the magnitude, which means the length of the vector, which is always positive. So therefore the value is 6. Now what is cos alpha? Cos alpha is always x divided by magnitude, which is nothing but r. Magnitude of the vector can be represented as r. So cos alpha is always x by r, cos beta is always y by r, and cos gamma is always z by r. So now what is x here? It is minus 2 divided by 6. So therefore cos alpha is minus 1 divided by 3. Next cos beta. So what is cos beta? We have minus 4 divided by 6. So you will get the answer as minus 2 by 3. So cos beta is minus 2 by 3. Next, this is 4 by 6. When you cancel, you will get cos gamma as 2 by 3. So therefore, minus 1 by 3, minus 2 by 3 and 2 by 3 are the direction cosines of this vector. Next, if vector AB is 2i minus j plus k and vector OB is 3i minus 4j plus 4k, find the position vector of OA. First, let us write AB. So vector AB is nothing but vector OB minus vector OA. So now I need vector OA. So therefore, let me shift it here. Vector OA can be written as vector OB minus vector AB. That means I have to subtract OB and AB. So now let me subtract. OB is 3I minus 2I. I can write it as 3 minus 2I plus minus 4 minus of minus becomes plus 1j plus 4 minus 1k. Just subtract the components of the vector, you will get the resultant vector. So now I have I minus 3j plus 3k. So this is the position vector of point A. Next, show that the points A 2I minus j plus k, B I minus 3j minus 4k, C 3I minus 4j minus 4k are the vertices of right angle triangle. So we need to show that they are the vertices of right angle triangle. So to verify that they are the vertices of right angle triangle, we need to satisfy the Pythagoras theorem. That is, if a triangle is of side ABC, then we should show that BC square is AB square plus AC square. So this is the condition. If a triangle is right angled at A and whose hypotenuse is BC, then we have to show that square of hypotenuse is always the sum of squares of the other two sides. Now let me satisfy this. First, let me find out what is vector AB, what is vector BC and what is vector AC. Then we will take the square of it and let's see whether it satisfies the given condition. Now vector AB means OB minus OA. So therefore here B minus A means 1 minus 2I plus, next I have minus 3, minus of minus 1 become plus 1j plus minus 5 minus 1k. So therefore here vector AB is minus I and minus 2j and here minus 6k. So this is vector AB. So now let me take magnitude of vector AB. Magnitude of vector AB is square root. So therefore if I take square on both sides, then I can just write it as minus 1 whole square plus minus 2 whole square plus minus 6 whole square, which is 36 plus 4 plus 1, 41. So magnitude of AB whole square is just this, a square of the components. Now let me take vector BC. So let me take this as equation 1. Now BC means C minus B. So therefore it is 3 minus 1 I plus minus 4 minus of minus 3 becomes plus 3j plus minus 4 plus 5 becomes 4k. So therefore vector BC is 2I minus 4 plus 3 is minus j minus 4 plus 4 is k. So vector BC is this. Let's see magnitude of vector BC. Let's take a square of it. Then it is 2 square plus minus 1 whole square plus 1 square. So 4 plus 1 plus 1, 6. Now let's take AC. So AC, vector AC is, so 3 minus 2 we have for I. So let's write 3 minus 2I plus minus 4 plus 1, minus 4 plus 1 j plus minus 4 minus 1, minus 4 minus 1 k. So now vector AC is I minus 4 plus 1 is minus 3j. Next, minus 4 minus 1 is minus 5k. Now let's take magnitude of vector AC. Let's take a square of it. Then it is 1 square plus minus 3 whole square plus minus 5 whole square, which is 25 plus 9 plus 1, 35. See, now let me take this as equation 2 and this is equation 3. Now observe, from equation 1, 2 and 3. If you take the sum of BC square and AC square, that is BC square plus AC square, the length is equal to AB square. So 35 plus 6 is 41 and AB square is also 41. That means AB will be the hypotenuse and the other two sides will be BC. So that is, the sum of the other two sides is equal to the square of the hypotenuse. So therefore, we can conclude A, B and C are vertices of right angle triangle. So now we are moving towards the section formula, which is a very important question for 3 marks in your examination. So what does the section formula says? Suppose if R is a point which divides the line PQ in the ratio M and N. So here the line is nothing but the vector PQ. If point R divides the vector in the ratio M and in the ratio N, that is M is to N, then we need to show that the position vector of this R, the vector R is M into vector B plus N into vector A divided by M plus N. Now let me take a vector PQ. So let me consider this as origin O. The position vector of P is OP, which is nothing but vector A. Position vector of Q is OQ, which is nothing but vector B. Let me consider one point R on the vector PQ, which divides the vector in the ratio M is to N. Then OR, that is vector R, will become the position vector of the point OR. Now here I have taken internal division of the vector OP. So therefore, I need to show that vector R is equal to MB plus NA divided by M plus N. Now here, if I have write from the figure, you can see PR. So PR by QR is nothing but M by N. PR by QR is nothing but M by N. So this is vector PR and vector QR. Then I can write this as N into PR, M into QR. How I can write PR? PR can be written as vector OR minus vector OP. M into QR can be written as vector OR minus vector OQ. So now here N into, so this is vector R minus vector A is equal to M into vector R minus vector B. So if I take R divides the vector PQ internally in the ratio M is to N, then from the figure I can write vector PR divided by vector RQ is equal to M by N. Or I can write N into vector PR is equal to M into vector RQ. Now the position vector of PR can be written as vector OR minus vector OP. So this is again using the triangular law addition. So see here, OP, PQ is nothing but OQ. So therefore, similarly if you observe this triangle, OP, PR is nothing but OR. So therefore, if you want PR, then it is always OR minus OP. Again here, M into vector OQ minus vector OR. Again from the triangle ORQ. So using the triangular law of addition, so if you want RQ, this is always OQ minus OR. So now here vector OR is nothing but R and this is A. Here it is vector B minus vector R. On multiplying, this becomes NR minus NA is equal to MB minus MR. Let me shift MR here, NA here. Then this becomes MR plus NR is equal to MB plus NA. Let me take R as a common factor. Here I will get M plus N is equal to MB plus NA, or vector R is M into vector B plus N into vector A divided by M plus N. So this is the position vector of the point R which divides the line or the vector PQ in the ratio M is to N, and it is given by vector R is equal to M into vector B plus N into vector A divided by M plus N. Next, so the same section formula whenever the point is outside the given vector. So that is the point R is dividing the vector PQ in the ratio M is to N externally. So here let me take this PR as M and this RQ as N. So therefore, here I need to show that if point R divides the line segment PQ externally in the ratio M is to N, then the position vector OR is MB minus NA divided by M minus N. Now from the figure, again, I'll write this as PR by QR. So what is PR? PR is M. And what is QR? It is N. So again, using the same verification here, I can write N into PR is equal to M into QR. So N into OR minus OP, M into OR minus OQ. So now we have N into vector R minus OP is vector A, M into OR is vector R minus vector B. So you will get here N into vector R minus N into vector A is equal to M into vector R minus M into vector B. Now let me shift NR to the right hand side and MB to the left hand side. Then I'll get MB minus NA is MR minus NR. So now if I take R as a common factor, here I'll get M minus N and here it is MB minus NA. If I need R, then it is M into vector B minus N into vector A divided by M minus N. So this is the position vector of the point R which is dividing the line segment PQ externally in the ratio M is to N. Next. Now, so we have seen the point which is dividing the line segment internally or externally. Suppose if the point divides the line segment exactly in the middle, then what is the ratio of M and N? So here M is equal to N. M is equal to N. So in that case, the position vector of that point becomes vector A plus vector B by 2 because M is to N means the value of M and N becomes 1. So therefore we know that vector R is mb plus na divided by m plus n. Midpoint means it is dividing the line segment internally. So we know the position vector of point R which is dividing internally, that is m into vector b plus n into vector a divided by m plus n. If R divides exactly at the midpoint, then m and n value is same, that is which becomes 1. So therefore here I can take vector b plus vector a divided by 2 because m and n value are same, so it becomes 2, which is nothing but vector a plus vector b by 2. Hence, the midpoint of AB is always vector a plus vector b divided by 2. Next, if 3 points are collinear, we have to show that 3 points are collinear. Then how to show that they are collinear? So, if we have a line AC here, and if a point B divides the line in the ratio m is to n, so here ratio doesn't matter, but if the magnitude of AB, that is the length of AB and length of BC, when you add it, then if it is equal to the magnitude of AC, then they are collinear. So this is the application of vectors, you can say. So if AC is the line and B is the point which is dividing the line AC, to show that they are collinear, we need to show that AB plus BC is equal to AC. Next question. Find the position vector of a point R which divides the line joining 2 points P and Q whose position vector are I plus 2j minus k and minus I plus j plus k respectively in the ratio 2:1 internally and externally. So this is also 3-mark question. So for the examination, if there is no derivation of section formula, you can expect the question from section formula for 3 marks. So now internally means formula is mb plus na divided by m plus n. Externally means the formula is mb minus na divided by m plus n. Now what is the value of m and n here? M is equal to 2, n is equal to 1. Now vector p and q, so I can take it as vector a is I plus 2j minus k, vector a is minus I plus j plus k. So first, let us find the position vector of point R internally. Now let's write vector a here, I plus 2j minus k, and vector b is minus I plus j plus k. Now let's take the condition of internal. So then it is vector R is equal to mb plus na divided by m plus n. We know that m is equal to 2 and n is equal to 1. So let's multiply m into b. So m into b means 2 into this. So minus 2i plus 2j plus 2k plus n into a. So which is I plus 2j minus k divided by m plus n, which is 3. Now my position vector R is equal to minus 2i plus I is minus I, 2j plus 2j is 4j, 2k minus k is minus k divided by 3. I can also write this in the form of minus 1 by 3i plus 4 by 3j minus 1 by 3k. So this is the position vector of the point R which is dividing the line segment PQ internally. Now let's take the external condition, that is vector R is equal to mb minus na divided by m minus n. So mb is again minus 2i plus 2j plus 2k minus, so minus of I plus 2j minus k becomes minus I minus 2j plus k divided by 2 minus 1 is 1. So now minus 2i minus I is minus 3i. Plus 2j minus 2j get cancels. So no need to write the second component. Next 2k plus k becomes 3k. So this is the position vector of the point R, which is dividing the line segment externally. So thus in today's session we have learned how to write the position vector of vector joining 2 points as well as the position vector of point R, which is dividing the line segment internally as well as externally. So we'll meet you in the next session with a new concept. Until then, keep watching, keep learning, keep exploring. Thank you.